have a question and under the discriminant section we'll go for 2025 question. Right, there's a small difference between if you consider 2025 question, this question is slightly different than the other question. That's why I selected this question, because here if you consider from 2021 to 2025 there are similar type of questions are given to with the discriminant, but here there are we can see a difference. I'll read the question for you. Okay, here the question fx is given, fx is given x squared minus 2kx minus k squared minus 1, right? Here the question is, show that the equation fx equals 0 has non-zero real roots. What is the question? Show that fx equals 0 has non-zero real roots. Sorry, two non-zero real roots. Wait a second. Has two non-zero real roots, right? If we go through the questions from 2021 to 2025, each and every question in the first part you can see, show that the fx has blah 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 two real roots or something like that. Okay, show that the fx equal 0 has two real roots or equal roots or something like that. But here we have two conditions. We have to highlight those when you are reading the question. When you are reading the question, you can see there are two cases behind this question. First thing is two real roots, and the other one is non-zero. This one is case 1 and this one is case 2. Can you see? When you read the question, read carefully. Show that fx equals 0 has two real roots. If we say two real roots, that's a different story. If we say two non-zero real roots, we have a non-zero term in between, so we have to consider that as well. Two non-zero real roots, then the roots can't be 0. That is the meaning of this one, right? Okay, then everybody knows how to prove that the equation has the real roots, right? Everybody knows what is the logic behind the two real roots. Then discriminant delta case 1, delta should be greater than 0 or greater than or equal 0. It should be greater than 0, because if we have two real roots, we can't go for equal 0, because I think everybody can understand that one, because if you are going for the greater than or equal 0, we are considering the equal part. Then if we are getting the delta as 0, then we can't have two real roots, right? Then the condition would be delta greater than 0, right? Then we have to show that. Then we can substitute values. Before that, we have to check whether that is in the correct format. Then that is okay, because we can find the isolated x squared terms, x terms and the constants. Then we can straight away go for the delta. b squared minus 4ac, then we can substitute values for the b squared minus 4ac. Here minus 2k squared, 4, a equal 1, c equal this, right? Then 4k squared plus 4k squared and plus 4. We can factor out 4, k squared, 2k squared plus 1. Right? I have given you some patterns. Right? According to those patterns, 2k squared plus 1 would be greater than 0, because if you are putting values for the k, then k should be greater than or equal 0, but we are adding plus more or plus 1 more, then this one can't be 0, this one never be 0. So 2k squared plus 1 should be greater than 0, right? It should be greater than 0. Then we have 2 now first condition is okay, but because fx has 2 real roots, now it's okay, but we didn't prove non-zero real roots, right? We just proved the fx has 2 real roots, but we didn't say non-zero real roots. How to prove whether it has non-zero roots, right? In the other word, it is saying that the root of the fx can't be 0, right? How to check that one? How to check that one? What is the definition of the roots? Roots are known as the x values when y is 0, right? If we take the values when y is 0, those are called roots, right? Then here, if the equation is given, let's say by mistake, after putting a value for the x, we are getting 0, that means x is the value which we put is a root. Can you understand? Let's say I put like here, for example, here the equation is x squared minus 7x plus 12, right? The roots is 3 and 4. Roots are 3 and 4, right? If you put 3 for the x, right, if you substitute 3 for x, then the whole thing would be 0. 3 square 9, 3 into 7 is 21, 12 plus 9 is 21, 21 minus 21 is 0. Similarly, after putting 4 for the x, that also becomes 0, right? According to the theory, if you put the root for the x, then this is automatically going to be 0, right? But if we substitute a value which is not a root, then it can't be 0. For example, if you put 1 here, is it 0? No. See, 30 minus 4 means 7 means 6, then it is not 0 here. Similarly, we can say if x is not, the value is not a root, then it can't be 0, right? Here we will substitute x equals 0 to check whether 0 is a root. Can you understand what I am saying? We have to substitute we have to substitute 0 for the x values to check whether 0 is a root of fx, as I did here, right? Okay, we'll see 0 square minus 2k into 0 and k minus, and there is no x here, so we can write the last part as it is. 0, the final value would be k squared plus 1, right? Then, as we all know, k squared is a positive value, I mean the minimum value should be 0, then we are adding one more, then it can never be, it cannot be 0, right? It is never, it is, this one can't be 0, then we can say this one is not 0. So, n 0 is an 0 is not a root of fx. Hence, by considering all, these two cases, we can say fx has two non-zero real roots, right? When you read the question, identify what is there to be done, right? Here, two non-zero, each and every word in the question is really important, and you have to go one by one, right? Two non-zero real roots. 2 is a different story, and we have to prove that. I have already proved that thing. Here, non-zero, this is how you prove 0 is not a root of fx. By combining those two, we can finally write the answer fx has two non-zero real roots, right? You have to go for it. If you are going to, if you need to get the full marks of the question, you have to read the question carefully, identify the things to be done, and do the calculation accordingly, and get the final answer, right? Okay, write it down if you have not done properly.